so we have 3 logs, and we know that this log A is twice as large as log B. So if we go from log B to log A, it's times 2. But if we go from log C to log B, it's 3 times larger. Log A is 3 times larger than log C. So I tried to put some nice numbers in here that makes it easy. I thought that if this one is 2x, then this one gets multiplied by 3 to 6x, it's 3 times larger. And if I make this one 3x, and I multiply it by 2, I get 6x. So the diameters here are 6x, 3x, and 2x. And the lengths are the same. We know that the volume of a cylindrical shape is the area, pi r squared, multiplied by, in this case, length, because it's a log. And they all have the same length. So let's have a look. Let's first investigate. We'd be expecting it. What are we doing here? From here to here, we are doubling the radius, so we would expect the area of the front of this one to be 4 times larger. Compared with B, we'd expect the area of the front of the log, because we've got the dimension, radius, twice, radius squared would be 4 times larger on the area. For this one, we're increasing by a dimension of 3, the radius is 3 times larger, so we'd expect the area, which is radius squared, to be 3 squared larger. So we'd expect this one to have a 9 times larger area, and we'd expect this one to have a 4 times larger area. Let's use our math skills to work out whether that's right. The volume of A is going to be pi r squared times L. The radius of this one is 3x. The radius of this log, if the diameter is 3x, it's 1.5x, half of the diameter. And the radius of this one is x. So the volume of cylinder A is going to be pi times 3x all squared times the length. So 3 squared will be 9, so we get 9 pi xl. And we'll leave it in that. We won't solve it, we won't multiply by pi or anything else, because when we work out the volume of cylinder B, we'll be using pi, the radius of B, squared times L. The radius here is 1.5, so we get pi times 1.5 x all squared. This should be x squared. Multiplied by L. 1.5 squared, that's the same. 15 squared is 225. So that will be 2.25 times pi times x squared times L. Notice that this part is the same as that part. That's why I sort of put it at the end there. So everything else is the same, and here we've got 9, and here we've got 2.25. So if we're going to compare the volume of A with the volume of B, how many times larger is A than B? We just divide the volume A divided by the volume B. Volume A is 9 pi x squared times L, and volume B is 2.25 pi x squared times L. Pi divides by pi to give us 1, x squared divides by x squared to give us 1, and L divides by 1. So we have 9 divided by 2.25. If we multiply top and bottom here by 4, 2.25 multiplied by 4 will give us 9 on the bottom. And 9 times 4 will give us 36. So we get 36 divided by 9, so it's 4 times larger. And then we can do exactly the same thing for cylinder C. Volume C will be pi r of C squared times L, which will be pi times x squared times L. So if we're going to compare volume of A divided by volume of C, we're going to get 9 pi x squared L divided by pi x squared L. They're all going to cancel, giving us 9 times larger. So the area of volume of log A is 9 times larger than volume of log C, which is exactly what we'd have expected, because here we are doubling the radius, which will give us a 4 times larger area, and here we're tripling the radius, which will give us a 9 times larger area. And the length is the same, so the only thing that's different in this factor is the area, the cross-section of the log. So that's how we would do that.